So in this video we continue our discussion of limits graphically. Once again here we have a piecewise function. The piecewise function here is defined to be, I'm going to write it out so it shows up a little better. It's x squared plus 1 when x is less than 2. It's negative 2x plus 12 when x is bigger than or equal to 2. So this is a piecewise function. And again, we want to talk about both the limit and the function value. I'm going to do the function value first, even though it's written second here. F of 2. So we would go into our equation and say, well, 2 is greater than or equal to 2. So we would use the second equation to evaluate that. Negative 2 times 2 would be negative 4 plus 12 would give us a positive 8. So f of 2 is equal to positive 8. Now what about the limit? Well, limit is asking what's happening to the graph as we squeeze in towards 2 along the graph. And you see in this particular problem there's a bit of an issue. On the left hand side the graph's squeezing in towards 5. But when you take on values bigger than 2, the graph's squeezing in towards 7. And so since that doesn't settle in to one particular place, we say the limit does not exist. This is similar to the third numerical example we looked at, where the two sides were going in vastly different ways. Now in that example they were getting bigger in positive and negative directions, but here they're not settling into the same amount, so we do not have a limit. We do not have a limit here. We do have a function value, but we do not have a limit. Okay. Our fifth example involves this function y equals 4 over x plus 2. So here I'm looking at the graph of 4 over x plus 2. And one of the things I see on this graph is that I have a vertical asymptote. I have a vertical asymptote at x equals 2. So on the left-hand side here, as we're approaching 2, right, it's going down in the negative direction. And when we're taking on values above 2, it's going up in the positive direction. And it's going to keep growing towards infinity. At the bottom, it's going to grow towards negative infinity. So for that reason, the limit doesn't exist. All right, there is no limit here for this function. It doesn't settle into anything. And then what about f of negative 2? Well, if I try to put negative 2 into that equation, I got division by 0, and we can't divide by 0. So f of negative 2 is undefined. So here we do not have a limit, and here the function value is undefined. Okay, so still different, being a limit not existing and the function being undefined are different things. But they are kind of, in that sense, a little bit similar. The final example, this example, by the way, was like the third example we did numerically. It was actually modeled off that what was going on in that situation was a vertical asymptote. Our final example is an interesting function here, an interesting graph. And I'd encourage you to, look at the graph and this graph and zoom in. I have a static graph here, so I can't zoom in, but we're looking at the graph of y equals sine of 1 over x. And what we're interested in is what's going on here at 0. What's going on here at 0 on the graph. And so what happens to sine of 1 over x as x approaches 0? Of course, you're dividing by 0, and you can't do that, right, as you get close to 0. So what's actually happening here and why it looks like it's like all shaded in is this graph is bouncing up and down a whole bunch of times between 1 and minus 1. If you check the notes, you'll see I showed a table to kind of demonstrate what this thing's doing, why it's bouncing back and forth, or that it is bouncing back and forth between minus 1 and 1. So this limit doesn't exist because it oscillates. It's bouncing back and forth between two values over and over again. And of course, the function value is undefined because you can't plug 0 in. 1 divided by 0 is undefined. And so here we don't have a limit either, but unlike the vertical asymptote one, the reason's a little bit different. The limit doesn't exist because this thing never settles into a value. It's constantly bouncing back and forth. Whereas the asymptote one, it was continuing to grow in one direction. So this just keeps bouncing between two numbers. Okay, and so those are your 6 examples. If you kind of refer to those as you're working through these graphical limit problems in the homework, you should be in fairly good shape. And again, as always, if you have questions, please drop me a line.